Hello and welcome to this segment of Introduction to Autonomous Systems. If you recall, in the last session, while discussing the goal based agent, we came to one conclusion about its deficiency, that the quality of the achievement of the goal was not quantitatively measured. Even though we said that are you happy or not happy, but suppose somebody said I am happy, but how much happy? And that is where the crux of the matter was. So, what we are going to look at in today's lecture is how does one bring in a quantitative measure for achieving a particular goal through what we call concept of a utility based agent. So, let us begin our session today. Utility based agents employ a performance metric to measure the desirability of a particular way of achieving the goal, which means now we have a mechanism so that we can measure something in a quantitative manner. In fact, this is similar to internalization of the external performance measure in the form of agent function, which means there is an externally specified performance measure which the agent actually uses as its own function, which it tries to achieve, and in general it is called utility function. Thus, we see that if the utility function matches with the external performance measure, agent that chooses the actions to maximize its utility will be a completely rational agent. So, you now realize that our original objective of looking at a rational agent is probably going to be satisfied if we bring in the idea of a utility function or what we call a performance metric. So, let us look at a schematic of what such an agent architecture might look like. As you can see, it more or less has a similar architecture to a goal based agent, but now we have an additional input to the block, what I call how happy I will be in such a state, which means now there is a kind of a quantification of that happiness through what we call the utility, and utility function specifies or indicates the level of happiness that a person will have or a system will have when that particular utility is achieved by the actions of the agent. And you can see that now the actions are driven by that utility function. So, of course, we have a dotted line which indicates the feedback and then how the word evolves, what my actions do. So, everything remains what we have seen, except that now we have a utility function which takes into account the actual objective which has been set and the function which represents the quality of that achievement based on a quantitative metric. So, what are the features of such utility based agents? One of the very important and perhaps frequently encountered scenario is that we need to trade off conflicting goals when there are more than one. So, suppose you have 2 or 3 goals to be achieved. For example, suppose you are going with a vehicle, your goal is to reach in time, but also to reach comfortably. Now, to reach in time, the vehicle may need to accelerate, that may degrade the quality of the ride particularly if the road conditions are not good. So, now you will have to trade off between the comfort level that you can get and the time that you want to achieve, and this typically is done through giving them relative importance through weights. So, you could, if your time is of greater essence, you may give greater weightage to the time and lesser weightage to the comfort, but if the time is not of essence, you may give more weightage to the comfort and less weightage to the time. So, this way you can now bring in an idea of trade off, particularly when you have a quantification of what the final objective or in which way it is going to be met. It also helps us to take rational decisions even when environments are partially observable, unknown or uncertain, by creating the concept of expected utility. So, for example, when you really do not know many things, you can still create a utility function which is statistical in nature based on expectations, and you can say this is what I expect to be the utility. So, you could say that I expect to reach the destination by 2 o'clock. Now, depending upon whether you are going to actually reach or not because of uncertainty, it would ultimately impact the nature of the solution. So, in this manner we will find that a utility based agent which is able to handle uncertainty and conflicting goals is fairly close to an agent that can also be called intelligent, because now you are taking a decision which is directly alive to the quality of performance in getting the objective that is set before the agent. And as humans, subconsciously we keep doing this all the time, that depending upon our priorities, what we want more than the other, we keep doing this weighing of the goals in our own minds, and based on that we kind of take actions. So, the schematics for structure which is shown previously now can be written in the form of an agent program that we have seen for a couple of agents earlier also, and this can be used to implement the function. So, again we have a function, goal based or utility based, either there is a percept which goes, then global variables are rules, state, model, action, destination, or the best utility function. State, update state, state, action, percept, model, and the rule is matched with these parameters based on the utility, and that rule decides what the action is going to be taken. So, we can see that we not only keep track of the current state, but also employ a destination or a metric to take a decision about what action to take. So, now the action is not only driven by what is your current state, but what is the destination and the corresponding metric. Now, if we were to look at the level of intelligence that such an agent brings to our agentic system development, we can say that they are very nearly intelligent, but there is something which is missing, and that something which is missing is the concept of learning, because if the learning does not exist, then agent will only be working based on whatever is the design time knowledge or the pre-computed ideas which have been kept in the database. And in order for this agent to become completely intelligent, because that is our whole focus, intelligent rational agent, it has already become rational with the utility brought into the focus. Now, to bring in complete intelligence, we have to add the feature of learning as well, and this also has given rise to the concept of agents that are in a position to learn from various percepts and also self correct the functions, which means now depending upon the learning which happens from the various percepts, the functions can get modified, including the utility function, so as to handle the real world situations, which means you may go and modify the actual utility function depending upon the scenario as it emerges during operations. So, what is the concept and configuration of learning agents? So, this brings into focus an important branch of agentic AI, that is learning agents. So, these are those agents who, while operating in unknown environment, generate the requisite knowledge through percepts and then go back and update your knowledge base with new knowledge, which means if the knowledge does not exist, it will get added. If it exists, but it probably does not reflect the reality to the correct extent, it will replace that knowledge. But in both cases, there is always a change in the knowledge base when there is a learning. So, in the current AI based agents, you will find that learning type of agents are the preferred choice for a wide range of applications. So, just to get this concept in a better format, let me show you the architecture of such an agent. And now you will find that if we take everything from the utility based agent and squeeze that into that performance element, so that performance element that you see here is essentially a condensation of your utility based agent design. And then from sensors you get another path which goes to a critic, which is also getting a performance standard for comparison purposes. So, this is like a comparator. In fact, in some sense this is what is called a comparator, that it is comparing what the sensors are giving based on a performance standard, and from that the critic generates a feedback, and that feedback goes to the learning element, which is also part of the agent design. Of course, you have to set the learning goals as to what extent you want to learn, what is the form of learning that you want to have, and once you do that, there is a problem generator, which means it kind of generates a large number of problems, and output of those problems it goes to back to performance element, which then creates a knowledge which goes back to your learning agent, and learning agent in turn changes your performance element, which means the learning which happens through this goes and changes your utility based agent design, whereas the problem generator which generates lot of data for that utility based agent, it goes back as knowledge and knowledge base gets updated. So, now you find where this learning philosophy is making difference to your agentic design. So, and now you find that this performance element not really be only the utility based agent, it could be simple reflex, it could be model based reflex, it could be goal based, it could be utility based, it could be any of those agent designs. Any of them can be learning agent, including table driven. Even the table driven agent that we have seen at the beginning of the discussion can also make use of learning, and every time a learning would happen with a new percept, a new knowledge, it will go and update the table. So, if the table gets updated, the next time it operates, it has an entry corresponding to a percept which did not exist earlier, and it will take an action based on the new knowledge. And now you realize that an important component of this whole process is the critic and the problem generator, because that is what is generating the amount of data. See, the critic says that your performance standards are not being met by the percepts that they are getting. That is the feedback that it gives to learning agent. Now, the learning agent says that in order to make sure that I meet the performance standard, I need now a large number of problems for which I will generate solutions, and say that among those which of the problems or which are the scenarios which will meet the performance standard in the form of knowledge, that goes back and updates the knowledge database. So, if you look at the features of these kind of agents, so it is essentially the critic that I was talking about, which tells the learning element how well the agent is doing with respect to a performance standard. And that is what ultimately comes in the form of a feedback, and that feedback then generates a large number of problems which are solved in order to generate additional knowledge, and which of them fits goes back and updates the database. And as you can see now, problem generator suggests actions that will lead to new and informative experiences. It will generate a large number of actions and corresponding large number of informative experiences. Now, among those, you are going to choose which ultimately minimizes the gap between the percept and the performance standard. And once that gap is closed, you say, okay, this is the action, which becomes now new knowledge that for this percept, this must be the action. Now, there is a small, I would not say issue, but while doing this, because you are generating a large number of problems, in some sense it becomes suboptimal in near term, because if there is an issue of time, then the time taken by the agent to come up with the best possible action is going to be rather large, and you may actually not be able to meet the timelines. But then they have the benefit that they are exploratory in nature, and in the long term they provide a much better perspective to the agent, because it has generated so many scenarios. The agent gets a much better idea of what is likely to happen if this is there. So, it kind of has a much better handle on to the given situation, and that is the benefit of a learning agent and use of problem generator. So, let us say learning and the other type of agents, what do they do? So, now one thing we have seen is that learning is the process that actually is sitting outside of the performance element. So, which means that it is over and above your simple reflex or model based reflex or goal based or utility based, and it can be applied to each of those agents discussed so far. For example, if we talk about simple reflex, learning can happen directly from percept sequence with successive states of the environment. And we come to this last point, that learning agents have a unifying principle in that they use a process of modification of each component of agent to bring them closer to the information provided by feedback. The idea essentially is that you go back and start modifying each and everything, which ultimately will have a bearing on the whole objective of getting the performance as close to the set standard as possible. So, to conclude this, utility based agents aim to more crisply capture the qualitative metric connected to the happiness quotient. So, this is the fundamental objective of these kind of agents, that they are now attaching a kind of a number to what you mean by happiness, 10%, 90%, 85%, 60%. So, some such number would be attached to this quotient, and then the agent design would try to achieve that number to the extent possible. And then we have also seen that learning brings in the corrective feedback mechanism that significantly improves the agent performance and is applicable to all types of agent design philosophies. Of course, we have also noted that because of the presence of the problem generator, it is likely to be a suboptimal solution, but then it will also provide a much better long term perspective to the agent. So, with that we come to the end of this session. So, bye for now and see you in the next session.